All right, so this is our review day for sections 5.4 through 7.2, I think. So what questions do you guys have for me? What would you like to go over? All right, let's go. I'm just kidding. Tyler.
With the one equations like, let's see, I think it's the discrete random variables.
Discrete random variables.
Standard deviation squared is the sum of the mean minus, or sorry, x minus the mean squared. Is that the sum of those numbers times the probability, or is it the sum and then times the probability?
Okay, so you're asking about the formula for the standard deviation of a discrete random variable. So I think I'm going to read it. I'm going to write it on the board right as it's showed to you on your thing. So they've got two different formulas here. So one of them is, so this is the standard deviation for.
Isn't it variance? We're looking at?
Well, I'm looking at what your sheet says, so I'm going to put it, and it actually says standard deviation.
Oh.
So this is standard deviation for discrete random variable. I may have given you the variance, but it's just square root's the difference. Okay, so here's what it says. Sigma sub x equals the square root of sum of x minus mu squared times the probability of x. Okay, or another version of the formula is the square root of sum of x squared p of x minus mu squared of x. Okay, so which version are you doing, the top one or the bottom one? What's your question about?
Top one. And my question was if you're doing the sum of each of those times the probability, or if it's the sum of the percent first and then.
Okay, so if I were to add an extra set of parentheses in here just to make it super clear, I would bracket it like this. You're doing this product before you do the sum. Does that make sense?
Yeah.
Now, on the second one, if you prefer the second one, here's how I would do it. I would put the brackets like this. You're doing this sum before you subtract off the mean squared. Okay. So yeah, that one definitely practice, because that one's super easy to mess up. And is there an Excel function that you can check your answer? No. If you use the Excel function, yeah, you're good slam, because it's not even close. It's not even close to correct. Okay. All right, what other questions do you have? I see Chris is here now. Let me give you back your quizzes. But what other questions do you guys have?
Me will be mostly Excel techniques.
Excel techniques. Do you have a specific Excel question you want me to do?
Just the graphing, just to make sure I understand.
The graphing, like what graphing?
Like in the sample that you give us for 6.1, 6.2.
6.1. So, yeah, I mean, it's hard for me to make up problems in my head, but if you want me to,
I can, if I show you.
You have one?
Like, yeah. We create the histogram and then.
Oh, okay, yeah. So, tell you what, read me that problem and we'll do that one on the board. That's or on Excel. So let me start sharing here. Okay, so read to me that problem there that you've got, Victor.
According to research, 86% of all USA households have a cell phone.
Slow down. 86% of households have a cell phone. Is that it?
In a random sample of size 20.
A random sample of size 20.
What is the probability that exactly 15 own cell phone?
Okay. So technically, you don't have to graph that one to do this problem, although you could. So are you more interested in the graphing, or do you want to know how to do this problem?
I'm more interested in the graph.
More interested in the graphing. Okay, so rather than answer that question, we'll say create a probability histogram. Yeah, I can zoom in. Okay. So that's what Victor's more interested in, but yeah. So how would you do that?
You have to find combinations.
Okay, you have to find the combinations. We will need to do that eventually, but that's not going to be our first step. Yeah, we need to put our sample space. So our sample space, so we need our x and we need our probability of x. And oh yeah, you probably will need an apostrophe. Yeah, for the histogram you will need an apostrophe. So we'll go apostrophe 0, apostrophe 1. I always forget to do that. So way to go, Trevin. So we'll go down to 20. 20 is right there. Okay. So we've got my x's. I always like to center it. You don't have to, but I think it looks better. Okay, so now what? Okay, so how do we do the probability? Samantha. I'm trying to think if that's the right answer. That might be right, but that's not how I would do it. I'm not sure. That could be right, but I'm not sure. It's not the formula I would use. In fact, we'll leave it here, and I'm going to move this over, and I'll show you how I would do it. But I want to see if you guys come up with something better or different. Yes? Ah, she's going straight for the Excel function, equals binom dist. Can you use that? Yes, you can. So let's do the equals binom dist. We're going to find out if Samantha was right, because we can compare her answer. Okay, so binom dist actually walk me through it. So number of successes. So should I put in a 0 or should I click? If I click that 0, it'll make my life easier. Number of trials, 20. Probability of success, 6. Do I want the cumulative?
No.
Should we vote? Who says false? 1, 2, 3, 4, 5, 6, 7, 8, 9. Who says true? There's more than 9 people in here. Who says I don't know? Okay, I've got 3 honest people. Okay, yes, it is false. That's correct. Okay, oh, look at that. That's exactly what Samantha did. Okay, now, there's a couple ways to do this, but I actually did pick the easiest way. Okay, now I can just simply copy this down. Okay, now what, Victor?
And I think we go to insert, right? Can we do the graph now?
Insert, just like this.
First select both.
Oh, I gotta select both columns first. Okay, good.
Select
All right.
both data.
I was going to do that wrong, and then you could see. Then can I do it wrong so you can notice that it was wrong?
I realized that I made them.
Okay, no, I understand. But what I'm saying is that for those of you who are taking the test, would you like to see it wrong so that you can recognize that it's wrong?
Yes.
Okay, so if we did it here, okay, insert, pick our chart, 2D. Now, yeah, this one's really sneaky because then I'm going to do this. This is wrong, but it looks right. What's wrong about it?
exactly the same as the one I did. It's actually.
Okay, yes.
No,
So-
21, that's why. The second one, it's not going to.
Yeah, that's exactly right. It doesn't start at 0 and it goes to 21. We only have 20. So that's a very subtle problem there. So yeah, make sure, so Victor, good job, notice that beforehand. Make sure you select both columns, include the column headings. You can do the exact same thing. Insert, 2D column, quick layout. There we go. Okay. Now it goes from 0 to 20. Okay. So pay attention. That one's really easy to miss. Okay. All right. Now what should I put down here?
Number of households.
So this is number of households with a cell phone. And this is
Probability.
probability. What should I put up here for my title? Yeah. This is probability of household out of 20, right? So the 20 is very important to there. With cell phone. Okay. You gonna ace my test?
I hope so.
Me too. Okay. Samantha.
So with this problem, if you just focus on 15,
In the random sample of size 20 was probably exactly 15. Yes, you could. Now that you've got it done here, you can just say, well, it's there. Or you could have just went straight there. Okay. Now, Jacob mentioned something about combinations. We didn't use any combinations, and I said we could do that. Can we do that? You can do it that way too. You want to do it that way?
I just remember you did a bunch of examples where we had to do like a huge combination.
Yeah. Yeah, this is one of those, okay? So we can do the combinations. Combinations. We can do our p to the x, and we can do our q to the n minus x. Okay? So we can do it that way as well. We should get the same answer. Okay? So, Jacob, do you want to take it away?
You hit equals combination,
Combin.
and then you click on, so you do 20, and then comma 0.
20
And
comma,
then you
click on the 0. Okay? Should be one of those. And then the p to the x should be?
The P would be 0.86.
0.86
0.
to the, click on that, 0 power. Okay. And what do I do here?
You would do 0.14 to the 20 minus 0.
20 minus, click on the 0. Because you want to put the minus 0, even though technically on the first one you don't need it, you'll need it on the rest of them. So might as well put that here. Now, by the way, should I have F4'd any of those? No. Okay. And now, when I do my probability, I just multiply these three numbers together, and hopefully this column is exactly the same as the one that Ashley gave me. So now I'm going to copy these down. And we'll compare this column here with this column here, and hopefully they match. Looks like they do. Okay, exactly the same. Okay, so you're welcome to do either method. If I give you one like this on the written test, you're going to have to do it this way. Of course, I'm not going to give you 20. That would be the whole test. Okay, so this is more likely a computer problem. But I could give you this. I could say in a random sample size 20, what's probably exactly 15. That would be a fine written question. And so if that were the case, you would simply multiply those three numbers together to get that. That's definitely doable on a written test. but I wouldn't make you do the whole table. Okay? Aren't you glad I'm letting you use Excel? Would this suck with a calculator? No, it would suck. Okay? All right, what else do you got? By the way, let me just mention this really quickly before I answer your question, Kat. What is the formula that we used? I mean, I kind of did it without, because I've got it memorized, but do you guys remember what that formula is that I actually did?
Combination.
So the probability of X equals the combination
P to the X.
n choose X, P raised to the X power, Q to the n minus X power. I believe in here that instead of Q, they got 1 minus P. I like Q better. But anyway. Tanner, you had a question.
So how do you know whether it's true, false, and cumulative?
Ah, great question. How do you know when it's true or false? Okay, so the one that we did was false, right? How do you know it's true?
If it's true, then you have to include everything. It doesn't include everything below.
Yeah, it's going to be probability that X is less than or equal to whatever that number is. Okay? This, in the false case, it's the probability that X equals whatever the number is. Just plain old equals. So equals is false, less than or equals to is true. What if it's greater than or equal to?
And you have to do true twice.
1 minus true. Okay? There was another question. Was it you? You got an answer. Okay. All right, what else do you got? Samantha.
How do you know, like, we have all these equations for different ways of finding standard deviation for different things. How do you know which one?
All right, so the question was, I don't know if you could hear that. We got all these standard deviation formulas. How do you know which one to use? Context, okay? So if you want, I can write them all down here. I don't know if you want me to do that, but do you want me to do that? Let me stop sharing. Okay. But basically, it comes down to context. So once again, this one here, is that still on the board? Oh, it's off the board. This one here in red, this is for a discrete random variable. So in order for this to be the case, you have to have a discrete random variable. Okay? If it's continuous, okay, you need to ask what kind of data it is. So if it's raw data, you'll probably use, well, at this point, I'm not going to make you do anything. If it's raw data, if I gave you raw data, it's probably going to be just stdev. It equals that, okay? If you're using Excel. If it's grouped data, okay, so then you're going to have to use the group data formula. If it's binomial data, well, binomial is not continuous. I probably shouldn't put it under there. If it's binomial, now binomial is discrete. Now discrete actually will work with binomial data, but there's an easier formula for binomial data. You guys remember what it is? We're talking about, yeah.
Square root of n PQ.
Square root of n PQ. Okay? Although you could do it with this formula, you should get the same answer. Okay? Any others? We're going to come up with more, just so you know. So, how do you know which one to use? Context. Yes. The formula for group data is So yeah, the formula for group data is, it's actually in chapter 3, sigma equals the square root of the sum of xi minus mu squared times the frequency. Sorry, that should be s of I. Divided by either the sum of the frequency, well, that's what I've got here. There's lots of different formulas. I'm going to subtract 1 if it's a sample rather than a population. This is the one for population. Subtract 1 if it's a sample. Yeah, there's going to be lots of different ones. We're not done with standard deviation formulas yet. Yes. How do we do factorials in Excel? Good question. Anybody know? Equals fact. FACT, and then you can put in whatever number you want. It will blow up. I want to also do 1,000. I think that'll blow it up. Yeah, that blew it up. Wonder how big we can go. Let's go 500. Oh, that blows it up to 250. Oh wow, I thought I could go higher than that. I'm pretty sure it'll do 100. 100 is pretty big though. Okay, somewhere between 100 and 250 it blows up. Permutations, permut. Okay, and then your number is, 150 and 75. I don't know, whatever it is. I don't think you'll ever get anything that big. That's big. Oh, it didn't blow it up. I was surprised. Okay. Combinations equals combin. Let's go 200 and 100. Let's see if I can blow this up. Oh, wow. How about that? Pretty good. That's better than your calculator. It's a good thing I'm not letting you use your calculator on these. What else you got? What'd you say? Bless you. Oh yes, Sean.
So for like example, in question 1 in the quiz,
Okay.
we talked about x is less than 80. What if it's less than or equal to? Is there a difference in that?
Okay, so the question was, on the quiz today, the probability was x was less than 80 versus probability that x is less than or equal to 80. Is there a difference? What's the answer to that? What'd you say?
A difference because in one you're going to count 80 as part of the whole.
Okay,
And in the other case, you count no.
so one counts 80, one does not. So here's what I would say. The answer is it depends. Okay? It depends on what kind of data you have. If you have discrete data, these are different. If you have continuous data, they're exactly the same. Why is that? Because if it's continuous, if I have continuous data, what's the probability that x equals 80?
0.
Equals 0. So it doesn't really matter. If it's discrete, it matters. But if it's continuous, it doesn't matter. Okay? So I think our quiz today was continuous, wasn't it?
Are we going to see any discrete on tests?
Absolutely. And in fact, that's a crucial distinction. So one of the questions you should always be asking yourself, in fact, that's going to come up later in chapter 7, is it continuous or is it discrete? Okay? Because how you handle these is different depending on the answer to that question. Okay? Discrete, these are a big difference, or potentially can be a big difference. Continuous, doesn't matter. So we'll blow your mind next week. Okay, when we make a discrete distribution continuous. Yeah. Okay. All right. Yes. I see.
So if you wanted to find the probability of discrete, would it use a normal distribution graph? What we just did.
Well, that's a great question. If we use discrete, we wouldn't use a normal distribution graph. That's next week. I'll answer that question next week. And that's what I was actually talking about, blowing your mind. So yeah, you don't have to worry about that today, but you will next week. Okay. All right, so I will post this up on Canvas. So reminder, you can take the computer exam today, tomorrow, or Friday. Oh, I didn't put it up there. Yeah, I'll have to do it right now. So yeah, the test will be up there. I think, what's the earliest you can get to the testing center? I think it's 10 o'clock. Yeah, so I've still got an hour.
It's a long test, should I take more than an hour to make it?
Well, you know my test. Yeah, plan on more than an hour probably.
Is it any different in length or layout than your previous ones?
No, it shouldn't be any different in layout, length. You know, some of you guys will take it hours if I give it to you.
So just be like
I'm giving it to you.
4
Take it
questions.
hours. Five.
5.
Five.
Thank you.
All right, see y'all.